Imagine this. You're 33,000 feet above the ocean, higher than Mount Everest. Below you, the vast, unforgiving blue. But you're not alone. You're clutching something impossible, an indestructible tetrahedron designed to pierce anything. Your mission? To jump, to hit the water, and to survive. Is it even possible? Or is this a one-way ticket to oblivion?
This isn't just a wild fantasy, it's a fascinating thought experiment that pushes the boundaries of physics, human endurance, and the very nature of matter. Today, we're diving deep into the science behind this impossible scenario. What truly happens when an unstoppable force meets an immovable object? Or in this case, an indestructible object meets the seemingly soft surface of the ocean at extreme speeds. First, let's talk about the fall itself. From 33,000 feet, you'd be falling for a significant amount of time. As you accelerate, air resistance becomes a major factor. Eventually, you'd reach what's called terminal velocity. For a human, that's roughly 120 to 180 miles per hour, depending on your body position. But what about our indestructible tetrahedron? Its aerodynamic properties would be very different, likely reaching an even higher terminal velocity due to its sharp edges and potentially higher density, cutting through the thinner air at altitude. Now for the moment of truth, hitting the water. You might think water is soft, but at high speeds, it behaves like a solid. This isn't just a figure of speech, it's a brutal physical reality. The surface tension of water, combined with its density, creates immense resistance. When an object impacts water at terminal velocity, the deceleration force is astronomical. Think of it like hitting a concrete wall. The water can't get out of the way fast enough. Adding to this, we have cavitation. As our tetrahedron slices through the water, it creates low pressure zones behind it, forming vapor bubbles. These bubbles then collapse violently, generating powerful shockwaves. While our tetrahedron is indestructible, these forces are still very real and incredibly destructive to anything around it.
But wait, we have an indestructible tetrahedron. Doesn't its sharp, piercing shape make a difference? Absolutely. A sharp object will penetrate water more efficiently than a blunt one, reducing some of the initial splash and allowing for deeper penetration. And the fact that it's indestructible means it won't deform or break. However, the sheer kinetic energy it carries at terminal velocity must go somewhere. It will be transferred to the water, creating massive displacement, huge waves, and still generating incredible resistance.
Now, for the most critical question, what about the person inside? Even if you are perfectly shielded by this indestructible tetrahedron, the laws of physics are relentless. When the tetrahedron hits the water and rapidly decelerates, you inside it will also decelerate at the same terrifying rate. This is where G-forces come into play. Humans can typically withstand about 5 to 9 Gs for short periods. Fighter pilots undergo rigorous training to handle these forces, but a sudden impact with water at terminal velocity, we're talking hundreds, possibly thousands of Gs. This isn't just uncomfortable, it's instantly fatal. Your internal organs, blood vessels, and bones would be crushed, torn, and liquefied. Your brain would slam against your skull. Even if the tetrahedron remains pristine, your body would be utterly destroyed from the inside out. It's like being in a car crash where the car is fine, but you're not.
So, the answer to our impossible question is a resounding, and perhaps gruesome, no. Even with an indestructible tetrahedron, the physics of high-speed water impact and the limits of human physiology mean this is a one-way trip. It's a powerful reminder that while imagination knows no bounds, the laws of the universe certainly do. What other impossible scenarios would you like us to explore? Let us know in the comments below. If you enjoyed this deep dive into extreme physics, hit that like button, subscribe for more mind-bending science, and ring the notification bell so you don't miss our next video.